Okay, in this we are going to look at the limits of functions. So what we have here is a limit as x goes to infinity. Just as a sort of quick remark with relation to a couple of the ones we have later on, that's plus infinity there. So here's our expression here, 5x squared plus 3x minus 4 over x squared plus 1. What we're going to do here is we are going to divide each term by the highest power of x. Now, the highest power of x is x squared. So what we're going to do is multiply through the whole thing again, and we are going to write out the whole thing again, but this time we're going to divide by x. So 5x squared divided by x squared is just 5. 3x squared divided by x squared, that is 3 over x. Minus 4 divided by x squared, we have minus 4x squared, 4 over x squared. X squared divided by x squared, we have 1 plus 1 over x squared. Now, what do we do now? So we have 5 and 1, but we have all these other expressions here. Now, as x goes to infinity, 3 over x, that's 3 over a larger and larger number. So that will go to 0. The limit of that is 0. Okay. Likewise, the limit of that is 0. It's a sort of 4 divided by an infinitely large number. So the larger you're dividing your by, the smaller your result is until it gets to 0. And likewise down here. So the answer is just that all those values go to 0. So it cancels down, and we are left with 5 over 1, or in other words, 5. That's the answer to the first one. So that's the first example. Let's look at another example. I've got a few of these. Limit as x goes to infinity, 3x plus 4 divided by x squared plus x. Now what we're going to do is divide by the highest power again, and we're going to get a slightly different answer this time. So this is x squared, this is the highest power. So let's divide through, re-express the whole thing, dividing through by the highest power. So 3x divided by x squared, that's 3 over x. 4 divided by x squared, well that's 4 over x squared. 1, or x squared divided by x squared, we get 1. And x divided by x squared, we get 1 over x. The same thing again, a lot of these are going to cancel out, or sort of go, the limit of each term is 0. That goes to 0, that goes to 0, and that goes to 0. So what we're left with is 0 over 1, or in other words, 0. So the answer to that one is 0. One more, actually there's a few more of these. The highest power this time is x divided by 3. Okay. So what are we going to do here? Let's divide through by that. So x divided by 3. And what we're going to do now is divide out by x to infinity, or x as x goes to infinity. We have 1 plus 3 over x squared minus 1 over x cubed all over x squared divided by x cubed is 1 over x. 7x divided by x cubed is 7 over x squared. And finally 3 over x cubed. Okay. Essentially it has, if it's something divided by x or x squared or x cubed, it goes to 0. So that goes to 0, that goes to 0, 0, 0, and 0. Oops. So 0 there and 0 there. So what are we left with here? We're left with 1 divided by 0. How do we have 1 divided by 0? How do we interpret that? Essentially what we're going to do is say that essentially the limit of this function here, we're going to say that the answer is plus infinity. Okay. Now it's important there that I actually emphasize the plus part. Okay. Because we could have minus infinity if you just think of the number line. Plus infinity and minus infinity are the two extremes. Just as a remark, 1 is a positive number, so that's how we know to go with plus 1. Just say for argument's sake was minus here, minus 1, we just might say minus infinity instead. That's not the case, but it's just how you would sort of cope with that in that situation. Now, what I'm going to do is actually look at some other examples, but you just notice this time we have x goes to minus infinity. In this case, we just have to sort of know how to sort of deal with that in relevant situations. In this situation, actually, as x went to infinity, x went to positive infinity. So actually, I'm just going to sort of remark that was plus infinity. Okay, so that we had dividing by a positive number by a positive number. Okay, plus infinity being a positive number. Here we have a negative number, so just watch out for that. For the forthcoming examples. Limit of x as x. Oh, my pen's got. Okay, I'll just write this bit and then just change the font. There we go. So what we're going to do is essentially what we did all previous examples. We divided by the highest power. The highest power here is x squared. So we have 3 divided by x squared is 3. 2x divided by x squared is 2 over x plus 1 over x squared. 2x squared divided by x squared is 2, plus 3x divided by x squared is 3 over x, and minus 5 over x squared. Okay, so essentially it becomes 3 over 2. All these terms go to 0. Okay, and sorry, there's a minus sign down there, minus infinity. That doesn't really have any bearing in it because there's no x as part of what we have left. The answer to this one is simply 3 over 2. Nice simple one. This one, not so much. Not as simple. Or actually, no, sorry, it's not this one, it's the tricky one. What we're going to do here is divide by powers. The highest power is x to the power of 4. So what we got, limit as x goes to minus infinity. 5x cubed divided by x4 is 5 over x plus 3 over x cubed. 9x to the power of 4 divided by x to the power of 4 is just 9. Minus 4 over x plus 4 over x to the power of 4. In this case, 0, 0, 0, and 0. So we left with 0 over 9. And so the answer to this one is 0. No, sorry. 9. Yeah. There's another way of doing that actually, but yeah, that's fine. Okay. So, last one, or second last one actually. X to the power of 5 plus 1 divided by x plus 1. So essentially, I'm just going to sort of remark though that I've done it a slightly different way. This actually, if we just disregard this term here, or those terms there, essentially what happens is that this function behaves like x to the power of 5 divided by x squared, which is x cubed. Okay. Now, so this is actually a very helpful way of looking at things. Just look at the highest powers. In this situation, what happens with a negative number when it's cubed? Okay. So in the last example, I'll just go back here. This is sort of pretty simple example, so I could have done it a number of ways, but I've done it the way we've sort of done previously. But this example, I'm going to sort of be a bit more circumspect about it. So this is the technique. So we just sort of disregard the lower powers and just look at the higher powers on the numerator and denominator, and we look at them specifically and divide them out. X to the power of 5 divided by x squared, we will get x cubed. Now, just see, as x becomes larger and larger to negative values, okay, the absolute value gets larger, so it sort of becomes a much larger negative number, so to speak. What happens with x cubed? Well, let's just remark that a negative number cubed is also a negative number, okay? So if you're the cube of a negative number is also a negative number. So if you get me, so if you have a number that's getting larger and larger in a negative sense, x cubed gets larger and larger in a negative sense. So the limit of this one is minus infinity. This one required a bit more thought than the previous examples. Okay. So it's not just a sort of cancelling things out. It's required a bit more thought to it. Here's another example. This is the last example. We're going to do this the same way. X to the power of 4 divided by x squared. We will get x squared there. Okay. Now, what happens with x as x gets larger and larger in the negative sense, so it becomes like minus a million, minus a billion, minus a trillion. What happens to x squared? Well, x squared is a positive number always. So the limit for this one is plus infinity. Okay? So it's just actually be mindful, again, just to sort of look at the dominant terms and just sort of focus on them specifically and just be careful, just to sort of think it through and isolate it down to a term like this and think it through. Okay, I'm going to come back to this now in another video.